So log base a of x means a to what power is x? Okay. If I were to write this out, a to what power is equal to a to the x, what fills the question mark? X does. So part of what we learn here is, as I said before, log base a and base a are inverses, and they cancel, leaving you with only x. Similarly, a to the log base a, those are inverses as well. They cancel each other out and leave you with x. It is these three properties of logarithms that we will use over the course of the next couple weeks here. So express the following in exponential form. I take the base. This reads log base 2 of 32 is equal to 5. This is a base. The 5 is an exponent. So if I were to write this in exponential form, it would read 2 to the 5th power is equal to 32. Change D to 5. Problem I miswrote many years ago, never changed. B, how would I write B? 6 squared is 36. How about C? 12 to the 0 is 1. D, 3 to the 5th is 243. So what's different about E and F? This reads natural log. So for example, if I were to write log of 100, that means 10 to what power is equal to 100? So what is the log of 100? 2. You can see that in this example, as my smartboard became stupid, there is no base written here. When there's no base written for a logarithm, the assumed base is 10. However, there's another special base other than 10. And that base is, come on, stop already. There it goes. All right. So, no. All right, so this is equal to 2. That means 10 to the second power is 2. So the assumed base is 10. It's not written. But if we have this, log base e of something, we write it as natural log. What is e? E is an exponential number that is used. I introduced it a little bit, I think, in the video on Friday. So now you understand a little bit about where the base e is used. We'll talk about that more later on. But right now in this situation, I have natural log. So this is also can be written as log base e of e is equal to 1. You don't have to write it like that every time, but I want you to understand that the base is e. So e to the first power is equal to e. How would I write the next one? What's my base? E to the 0 is equal to 1. A, 2 to the 4th is 16. It says express the following equations in logarithmic form. So now we have exponentials. We would like to express in logarithmic form, so the other way around. So I write log, and then I put my base. What's the base? 2. Logarithms solved for exponents. What is the exponent? 4 is the exponent. 16 goes here. Base, exponent, the other number. What's the base? 10. So you don't have to write 10. You can just write log of 100,000 is equal to, because 10's the assumed base. Just like if I have, say, 3x, I don't have to put 1 for the exponent. It's the assumed number. If you want to put the 10 there, you sure can. Next one, log base 8 of is equal to D, log base of equal to 0. Log base, so I won't write it, of a tenth is equal to negative 1. Next one, log base. So I don't write log base E, I write natural log. ln. Um, I think it's Latin. The word natural is first and then logarithm is second when they say it in Latin. So that's how it gets that. All right, natural log of E is equal to 1. I don't know if it's Latin or French. Anyway, we'll look it up. All right, so we flip it over. Okay. So we worked on working back and forth between exponentials and logarithms. Now we should be able to evaluate basic logarithmic expressions. Log base 4 of 64. That means 4 to what power is equal to 64? 3 to what power is equal to 1/9? Negative 2. 8 to what power is 8? 1. 5 to what power is 5 to the x plus y? X plus y. This is where we can use that rule that logarithms and exponential functions are inverses of each other. So when you see this log base 5 and then a base 5, you can just cancel those out and you're left with the x plus y. So look at my next one, 3 to the log base 3 of 7. That looks really confusing. But these are inverse operations of each other. I get rid of them. What are you left with? 7. Natural log of 1 over e squared. That means e to what power is 1 over e squared? Negative 2. We'll do example 4 and we're done. Log base 2 of x is equal to 3. That means a base of 2 to the third power is equal to x. So what is x? Log base x of 100 is 2. So that means a base of x to the second power is equal to 100. So what is x? 5 to the x is equal to 125. So x is 3. X to the 1/2 power is 49. So x is kind of want to say 7, don't you? Because the square root of 49 is 7. But that's not what it's asking, is it? It's saying what number would you take the square root of to get 49? And that would be 2,400 more. The next one, 2 to what power is 0? 2 to the 1 power is 2. 2 to the 0 power is 1. 2 to the 0 power is 1. No solution. Why? Do you remember Friday? Okay, so as we look at this graph, you remember from Friday that the graph of exponential functions have a horizontal asymptote in this situation of y equals 0. That means, does it ever cross the x-axis? So it can never achieve a value of 0. Okay? So therefore, in this situation, you would have no solution. Last one, log base 10 of x is equal to negative 3. That means 10 to the negative 3 is equal to Or 1 over 1,000. Very good. If you put off your homework during this unit, you're asking for trouble. Okay? This is a nice, easy assignment. You should be able to get through it pretty quickly. Tomorrow we will look at the graphs of these. I think it says graph for most of them. So what? There it is. Okay, so this was Friday's and this is today's. So that was for Friday. That's for Monday. So this time should go pretty quick. Maddie has the first question.